Now that we have the law of cosines, let's talk a little bit about when these laws of cosines might be useful. So these are going to be useful whenever you have given to you information that will cause one of these equations to have one unknown. So for example, let's say that you were given b, gamma, and a in a problem. Then a typical problem might look like find the other sides and the other angles. Now, if any of these three law of cosines have only one unknown in them on using the information that a, gamma, and b are known, then you'll be able to use that law of cosines to figure out whatever is unknown. So for example, let's go to our first law of cosines here. What do we know? Well, we don't know C, but we know A, we know B, we know A and B, and we know gamma. So if we were given A, B, and gamma, we could use this first law of cosines to figure out what C is. However, you wouldn't be able to use the other equations right away because let's take a look at the second equation. We know A and B, but we don't know C, and we don't know beta. So there are two things that we don't know in this second law of cosines equation, so we couldn't use it right away to figure out something that we don't know yet. Whereas in the first equation, there's only one thing that's unknown, C, and we can figure out what C is. Additionally, in the third equation, we can't use that yet either because, again, we know A and B, but we don't know C, and we don't know alpha. So there are two things that are unknown in those second and third equations. However, once we use the first equation to figure out what C is, once that is known, we will be able to use those second and third equations to figure out beta and alpha. Let's see what this looks like in an actual example. So let's find all sides and angles if A is 10, B is 12, and gamma is 30. Finding all sides and angles to a triangle is also known as solving the triangle. So let's solve this triangle. And although it can be repetitive from the previous slide, every time I do one of these, I like to draw my triangle and label the angles. And then once you label the angles, just make sure you label the sides with A opposite to alpha, C opposite to gamma, and B opposite to beta. And you can fill in what you know here. You know that A is 10. You know that gamma is 30, and you know that B is 12. Now we already talked about how we can use the law of cosines, but if I was doing this problem from the start, I would draw my triangle, and then I would look at the law of cosines and see, is there something that I can use here? Is there a law of cosines that I can use that I have exactly one piece of unknown information in that law of cosines? So essentially what I do is I have my law of cosines written out, and I circle the things that I know, and I ask myself, can I use any of these law of cosines in the sense that is there one with one thing unknown? And that's in this first law of cosines here, I have exactly C unknown. So I'm going to use this first law of cosines to find what C is. So I know that C squared is the sum of the other sides squared, so 10 squared plus 12 squared. Note that if this triangle is a right triangle, then this here would be a correct statement on its own. It would be the Pythagorean theorem. But this is not a right triangle, so I cannot use the Pythagorean theorem. I instead need to subtract 2ab times cosine gamma. 2 times a, which is 10, times b, which is 12, times cosine of 30 degrees. So if I type this into my calculator, making sure that my calculator is in degree mode, I get that C squared is 36.154 on rounding to the third decimal place. And then I'm going to figure out what C is by taking the square root. And when you do this on your calculator, when you do this computation here, it will store the result of this computation on your calculator. And then you can evaluate the square root by doing square root of answer. I advise that you do this because you avoid making a bunch of round off errors. So for example, this answer here is rounded to 3 decimal points, but in your calculator when it's stored, this answer is rounded to many more decimal points. And so when I do the square root of my answer in my calculator, I get 6.013 rounding to 3 decimal points. And so that determines what C is. So now if we go back to our law of cosines and we circle what we know in blue, now we know everything from the first equation and we know almost everything from the second and third equation. We know A, B, and C, and gamma. So we can use either the second or third equation to figure out beta or alpha. What I'm going to do is I'm going to figure out alpha from the third equation here. And then once you have alpha, you could use the second equation to figure out beta, or what I'll do is, since I know that gamma plus alpha plus beta is 180 degrees, I'll use this to solve for beta and find that beta is 180 degrees minus alpha minus gamma. But of course I need to know what alpha is before I can do that. So I'm going to take my third equation and I'm going to solve it for cosine of alpha. So I'll subtract b squared and c squared from both sides, so minus b squared minus c squared. So subtract it from both sides. Then what I'll get is negative 2bc is still on one side, so negative 2bc cosine of alpha is going to be equal to a squared minus b squared minus c squared. And then I can divide by negative 2bc on both sides, and I get what cosine of alpha is. Cosine alpha equals a squared minus b squared minus c squared over negative 2bc. And keep in mind that we know everything on the right hand side here. We know a, b, and c. So what I'm going to be left with here is cosine alpha equals some number. And also keep in mind that alpha has to be between 0 and 180 degrees because it's an angle of a triangle. If you have an angle of a triangle, alpha, then we know that the sum of those 3 angles together needs to be 180 degrees. So there's no way that alpha could be larger than 180 degrees. So what we're left with here is that cosine alpha equals a number. That number is, well, let's see, 10 was A, B was 12, I believe. So there's B, there's A, and then C is 6.013. So this is going to be 10 squared minus 12 squared minus 6.013 squared, all divided by negative 2 times B. B again is 12, and times C, which is 6.013. And that will be what cosine of alpha is, and this is just going to be some number. That is, this right-hand side is going to be some number. When I type this into the calculator, I get that this right-hand side is 0.555. So I know that cosine alpha is 0.555. And of course, I also know that alpha is between 0 and 180 degrees. And what that means is I can use the inverse cosine function to figure out what alpha is. So alpha is going to be cosine inverse of 0.555. And cosine inverse of 0.555, that rounds to 56.259 degrees. So 56.259 degrees. So now we have alpha, we have gamma, and now we have to figure out what beta is. And again, we can figure out beta by doing 180 minus alpha minus gamma. So this is going to be 180 degrees minus, actually let's do this computation on the next page here. So right here, so we have that beta is going to be 180 degrees minus alpha, which is 56.259 degrees, minus gamma, which is 30 degrees. And this leads to the value of beta, which is 93.741 degrees. 741. And now, very technically speaking, I really shouldn't put an equals because these are all rounded. So what you'll see often is this approximation sign, that alpha is approximately this because we rounded to 3 decimal places. Beta is approximately 93.741 degrees, and if I go back to my value for C, this C should really be an approximate. And now we've figured out all of the sides and all of the angles. There's C, and I pasted my work that I did for alpha and beta so I could list them alongside C, and that would be our answer.